Hello, everybody. So here we have problem 4.2, and we're told that we are a power plant which produces 10 to the power of 9 watts, which is equals to 10 to the power of 9 joules per second of electricity, and the temperature of the steam is equals to T hot, 500 Celsius, which is equals to, let's just say, 773 Kelvin. Instead, the temperature of the environment, of the cold one, is equals to 20 Celsius, which is equals to 293 Kelvin. So, for part A, what is the maximum efficiency? Well, the maximum efficiency is going to be equals to 1 minus T cold over T hot. So we have 1 minus, remember we have to use the Kelvin measurement. So we have 293 divided by 773. Oops, okay. And we get something to be approximate to 62.1%. Oops, okay. For part B, it says, what if you allowed the steam temperature to be raised to 600 Celsius? So we have 600 Celsius as T hot now, which is equals to 873 Kelvin. What is the efficiency now? Well, we can calculate it. Efficiency is going to be max, of course. It's going to be equals to 1 minus temperature hot. So again, always saying temperature cold minus temperature hot equals to 1 minus 293 divided by 873 is equals to about 66.4%. So now we have to find how much more money are we making? Well, we can find the difference in efficiency, the ratio in efficiencies. So we can find the ratio in the amount of electricity produced. So the efficiency from part B divided by the efficiency of part A is equals to then 66.4 divided by 62.1, which is equals to 1.069. So this is the ratio of the electricity produced. Just going to write it as electricity in B over electricity in A. So this is the ratio between those two because of the efficiency. So now that we know how much that is, we can find the difference in revenue to be equals to, well, in this case, if we use 1.069, we're finding the how much electricity are we producing in part B with respect to part A. But the difference in the electricity in part A, I'm going to write electricity, they're just going to be equals to 0.069. So I just plug this in for our difference because I don't want to calculate how much I'm making in part B. I just want to calculate the difference. 0.069, of course, times 10 to the power of 9 joules per second, because we said we produced the 10 to the power of 9 joules per second, now producing 0.069 more joules per second. Now, how many seconds are in a year? 3.16 times 10 to the power of 7 seconds per year. And then we have to convert from a kilowatt hour into joules and then from kilowatt hours into money, because we are told that the cost is 0.05 cents per kilowatt hour. So we have 1 kilowatt hour is equals to 3.6 times 10 to the power of 6 joules, of course, because of course we know joules and watts are the same thing. Well, 1 watt is equals to 1 joules per second. Oops. And then of course we have 60 seconds times 60 minutes in an hour. So we get 3600. So we have 3.6 and 10 to the power of 3 over here, but then we have 1 kilowatt, remember? So it's going to be equals to 1 times 10 to the power of 3 joules per second. So we were able to multiply these two, and we will get this bottom of the fraction. Okay, let me erase this part here because it's coming. Okay, times, again, what is it? How much are we paying per kilowatt hour? 0.05 cents. So $0.05 per kilowatt hour. And we end up with 3 times 10 to the power of $7. Well, actually about 3.7 $10. Oops. So there is the final answer to our problem. Hope that was helpful.